Today we're going to be looking at lesson 117, I believe. Yeah, so we're skipping 116, which involves simple and compound interest. We may come back and catch some simple and compound interest things, but we're going to jump on into lesson 117. And we're going to use trig ratios to solve right triangles. Now, trigonometry is what we're talking about here, right? And as you know, I'm big on the meaning of things, okay? And trigonometry. What is trigonometry?
Something to do with triangles.
Jackson?
The study of right triangles.
Not just right triangles.
It's kind of like trig.
So let's take the word apart. We know what metry is, right? What does it metry mean?
The study of metrics.
Do what? It is.
Study of metrics.
Y'all don't know what that suffix means? Metry?
I know ology.
Okay, means to measure. Now,
Measurement of triangles or three-pointed structures.
yeah, so a trigon is a three-sided polygon, right? A polygon, you've got an octagon, you've got a pentagon, you've got a hexagon, decagon. A trigon is a three-sided polygon. So the word trigonometry, guys, y'all listen. The word trigonometry literally means to measure triangles. Okay, so we're trying the whole course. And when you take trigonometry, you'll be maybe surprised how little. It's a small math class. Like it's way smaller than algebra. The specifics of trig, what you need to know for trigonometry for like the ACT is you're just about going to get all of it today. But what you're going to need to know for trigonometry for calculus, you can learn in a week. I mean, it's really not that difficult. There's not a whole lot. There's seven objectives in a college trig class. Most college trig classes. College algebra class has 20 plus. Just to kind of give you some kind of idea how many different things there are that you're going to need to know about trig. There's not a lot. Okay, so trigonometry is the measurement of measurement of triangles. Now, specifically, the foundation of triangles, or the kind of the building blocks of all triangles, are right triangles, because we can take any triangle that's not a triangle, and we can do what with it? We can always create right triangles from the triangles that we're given. Okay, so what we're going to do today, guys, is so you can measure. If you know trigonometry, you can construct lines and you can measure any triangle using right triangle kind of properties. All right, so let's dig right in. There are three trig ratios. You need all of this information. You got to memorize it, so start writing. Do not get behind. There are three trig ratios: sine, cosine, and tangent. Now, really, there's six, but the other three are just reciprocals of these three. So sine, cosine, and tangent are the only three trig ratios we really need to know. The others are identities related to these. If you flip the sine, you get the cosecant. If you flip the cosine, you get the secant. If you flip the tangent, you get the cotangent. So once you know sine, cosine, and tangent, you know all of the six trig ratios. So these three trig ratios, sine, cosine, and tangent. All right? In a right triangle, the sine of an angle is the ratio the sine of an angle. The abbreviation of sine, incidentally, is just SIN. The sine of an angle is the ratio of the opposite leg to the hypotenuse. Now, what is a ratio? It's a comparison of two numbers by division, right? So we could just write this as, sine equals the opposite over hypotenuse. That's what we mean by ratio. It's a comparison of the two quantities by division. The sine of an angle is the ratio of the opposite side to the hypotenuse. So it's the opposite side divided by the hypotenuse. The cosine of an angle is the ratio of the adjacent leg to the hypotenuse. Cosine of an angle is the ratio of the adjacent leg to the hypotenuse. So it's the adjacent leg divided by the hypotenuse. Okay, and the third trig ratio, the tangent of an angle, is the ratio of the opposite leg to the adjacent leg. Okay, so the sine of an angle is the opposite over the hypotenuse. The cosine is the adjacent leg over the hypotenuse. And the tangent is the opposite leg divided by the adjacent leg. Okay. Any questions there? Yeah, we'll talk about calculator in just a second, but that's what these buttons are exactly. Okay. There's three reciprocal ratios. Now these are you can call these reciprocal identities. They are ratios on their own, but they're related to the others. So we've got our three main, sine, cosine, and tangent. All of the other trigonometric functions come from sine, cosine, and tangent. Okay? The cosecant is the reciprocal of the sine. Okay? Yes. Extremely important. Yeah. Now, the abbreviation for cosecant is CSC. So the cosecant of an angle x is equal to 1 over the sine of x. The sine is the opposite over the hypotenuse, so the cosecant is the hypotenuse over the opposite side.
Wait, what was the abbreviation? Is that CSC or something?
That's cosecant, yes.
CSC.
Yes, CSC.
But isn't it opposite over the hypotenuse?
No, the sine is the opposite over the hypotenuse.
The
The cosecant is the reciprocal of that, so it's the hypotenuse over the opposite. Okay? All right, so the secant is the reciprocal of the cosine. So the secant of an angle, SEC is the abbreviation for secant. The secant of x is equal to 1 over the cosine of x. And because the cosine is the adjacent side over the hypotenuse, that means the secant is the hypotenuse divided by the adjacent side of the right triangle, adjacent leg of the right triangle. Okay? And then thirdly, the tangent is the reciprocal, the cotangent is the reciprocal of the tangent. The abbreviation for cotangent is COT. So the cotangent of an angle x equals 1 over the tangent of x. And since the tangent is the opposite over the adjacent, the cotangent is the adjacent side divided by the opposite side. All right? Yes, sir.
Oh, what adjacent and opposite?
We're going to talk about that next. So we're getting all our definitions, and now we're going to kind of have a look at this, okay? An abbreviation that a lot of people use to memorize these things is Soh Cah Toa. Soh Cah Toa, if you wanted to look on YouTube, there's a lot of there's even songs that you could do. I know Savannah loves it when I sing.
Isn't that a quote
But
from SpongeBob?
what this means here, guys, is that the sine function, sine is equal to opposite over hypotenuse okay. The cosine is equal to the adjacent side or the adjacent leg over the hypotenuse. And then tangent, of course, is opposite over adjacent. Okay, so Soh Cah Toa. Soh Cah Toa. Tangent is the adjacent, opposite leg over the adjacent leg. And then the cosecant is the reciprocal of the sine, so that would be hypotenuse over adjacent, opposite. Not sure why some of you stopped writing. Secant is equal to the hypotenuse over the adjacent, and the cotangent is equal to the adjacent over the opposite. Now, but for the most part, guys, you're going to use these three right here, and then you'll just reciprocate it if you want to find the others. Okay? So really what you have to be familiar with is your Soh Cah Toa. Sine opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the opposite over the adjacent. Okay? There's a couple of kind of limericks or acrostics that you could use here. Old horses are happy old animals. Okay? That one's a little bit, Christian school friendly. Public school in the hood where I'm from. Some old hippie caught another hippie tripping on acid. So, yeah, I'm hard like that. All right, so I love that it irritates you, Savannah. Okay, so here's what we're talking about, guys. Let's put this all together. If we have a right triangle, ABC, C will always be our default for the right angle. Little c is always the hypotenuse. It's the side across it. Angles of triangles are generally always labeled with capital letters. The sides of the triangle are going to be labeled with lowercase letters that are opposite, right? So if we're talking about angle A, which we are in this particular drawing, this is angle A. We could completely change our perception if we wanted to, but if we're talking about angle A, this leg right here is the leg that's adjacent to A, and this is the leg that is opposite. Okay? So opposite side to A is the side on the opposite side. The adjacent side is the leg that helps to actually create angle A. So the adjacent leg to A is always going to be touching A. Okay? You need to write this down. And of course, C is always the hypotenuse. Does this make sense? All right? So I could take this and we could talk about what the sine of A is equal to. What's the sine of A? Just using the variables here. It's the opposite over hypotenuse, so that would be A over C. Right. The cosine of A would be B over C, opposite, the adjacent over the hypotenuse, rather. Okay, and then so on and so forth. This is going to be a little bit nicer and more friendly when we're not in the abstract and we have some things to work with. Okay? Now, if I wanted to change my perspective here, if I wanted to talk about relative to angle B, what's the value of the leg that's adjacent to B? A is adjacent to B. And what's the value of the leg that is opposite B? Opposite B is B. C is the hypotenuse. It stays fixed. Okay? So let's just work into this. All right? Using the right triangle that's given here, find the sine of B, the cosine of B, and the tangent of B. So in your notes, you need to draw this right triangle, or else what you're about to write will make absolutely no sense. Just draw the triangle. Make sure it's labeled correctly. Sit up straight, please. Okay. What is the sine of angle B? What's the ratio for the sine?
5/13.
Opposite side over the hypotenuse. So the side that's opposite angle B is 5. The hypotenuse is 13. Okay? And that's it. I mean, we're just practicing a skill here. The cosine of B is equal to the adjacent leg to B is 12. The hypotenuse is still 13. Yes, Brent?
So when you put that in your calculator, how do you do it?
Can't use a calculator for this.
Like, what is sin, cos, and
We'll get to that in a minute. Okay? What is B in this expression right here? It's an angle. So what you put into your calculator when you're using sine, cosine, and tangent are angle values. We don't have any of these angles. We could find out what they are using the sine and cosine, but that's example 4. All right, tangent of B would give us what? The opposite side over the adjacent side. Now, we could use these to find the cosecant, secant, and cotangent, right? What would the cosecant be? Just 13 over 5. The secant would be 13 over 12, and the cotangent would be 12 over 5. So we're just trig ratios of right triangles. All right. Now let's have a look at this one. This says use the right triangle here that's given, so you'll need to draw this right triangle here. Make sure you draw it carefully. This one is a little bit more complicated because we're missing something, right? And this says to find all 6 trig ratios. To find the 6 trig ratios, we are going to find the 3 major ones and then reciprocate them. What's missing? Do what?
A value.
We're missing one of the legs, right? We need to find that leg. Can we find the leg?
yeah.
Now this goes back to what we've done previously. We need to find the value for A, and we're going to have to use the Pythagorean theorem. What would that be, Jay?
Squared plus B squared equals C squared.
Okay.
5 squared, no. A squared plus 4 squared equals 5 squared.
Good. A squared plus 4 squared equals 5 squared. Okay. That's 16 and 25, right? If you subtract 16 from 25, you get A squared equals 9, which means A equals 3.
Oh, 3.
Yeah, square root of 9 is 3. So we'll have 3 here. So this value for A is equal to 3. And now we're ready to do our trig ratios. Can't write there, that's 3. Okay, and so we could do sine of the angle A. Sine of A equals what?
Sine is opposite over hypotenuse.
So which side is opposite A? 3 over 5 is correct. The cosine of A is the adjacent side over hypotenuse. And then the tangent of A is equal to the opposite side over the adjacent side, right? So that will be what? 3 over 4. And then the cosecant of A is 5 over 3. The secant of A is 5 over 4. And the cotangent of A is 4 over 3.
Now, or is the sine cosine?
It's not difficult at all. You just have to memorize and learn how to deal with your
So is the
triangles.
sine, cosine, and tangent, are they always going to be less than 1?
That's a great question. What's the answer and why?
No.
Are the sine, cosine, and tangent always going to be less than 1?
Yes.
Why? Because I need a justification if I'm going to get an answer. Wilson?
Because hypotenuse is always going to be larger than.
The hypotenuse is the largest side of the right triangle, right?
Okay, so you know if it's correct, if the fraction's greater than 1.
Yeah.
you
So actually, it could be less than or equal to 1. Because we could have the hypothetical triangle that has a 0-degree angle in it, right? If there's an angle of 0 in a right triangle, it's a fictional triangle, right? But if we have an angle of 0, if this is 0 degrees, the side here that is, let's just say it's 1, and this would also be 1. So it could equal 1. This 0 is one of those special angles, right? And this opposite side would be 0 because the angle has no thickness, right? So the sine of 0 is 0 over 1. The cosine of 0 is 1 over 1. So cosine of 0 is 1. Sine of 0 is 0. So they can actually equal 1, but they can't go any further than that. All right? So yes, the cosine, the absolute value of the cosine of an angle is always less than or equal to 1, between positive 1 and negative 1. All right? Now, calculator. Here we go. Now this says find if the measure of angle A is equal to 42 degrees. And we need to talk about something here that's extremely important. Are y'all listening? Extremely important. There are 2 modes that we can work with on our calculators related to angles. Okay? One is called degrees, and one is called radians. Your calculator is defaulted to the radian mode. So the very first thing you need to do if you're dealing with a problem that has degrees in it, which is exactly what we're dealing right here, 42 degrees, is you need to press the mode key on your calculator, and you need to move over to degrees and hit enter to change your calculator into degree mode rather than radian mode.
What is radian?
Not going to go there. It's just another way to express angles. There's a conversion. Pi radians equals 180 degrees. That's the conversion rate. Okay, but that's for trig. You probably won't even do that in geometry. Okay. So to find the sine of this angle, once you turn your calculator into degree mode, you're just going to press the sine key, and then it'll open a parentheses for you. You're going to press 42, close the parentheses, and hit enter, and it'll tell you that the sine of 42 degrees is equal to what?
0.669130664.
To the nearest 10 thousandths.
Oh.
That's 4 decimal places, right? 0.6691.
One.
Is that correct?
Very correct.
Did everybody get that?
Yes.
Now, just to prove a point, change your calculator to radian modes and put that in, and you're going to not get the correct answer. Now, the ACT doesn't do this, but if they really wanted to be mean, they could put the correct answer for radians and the correct answer for degrees and just really punish you for having your calculator in the wrong mode. They don't generally do that.
If you do second plus 702, does that put it back?
It's going to put it back into radian mode. Radian is the default mode for the calculator. Okay, and because when this is a graphing calculator, and when you get into trig function graphs, you really want to deal with radians. because pi is 180 degrees. You imagine dividing up your axis into degrees. You got to go all the way to 360. So 360 is 2 pi. So you could go pi over 2, pi, 3 pi over 2, 2 pi, and you cover 360 degrees. Your graph is labeled. Because that's really where the interesting things happen with these functions. So radians should be the default mode for your calculator when you're graphing trig functions. In a trig class, you'll leave it there most of the time. Okay, to find cosine and tan, you do the same thing, right? So if the measure of if angle A is equal to 33 degrees, let's talk about how to do this. Find the cosecant of A. Now what I want you to notice is that there's not a cosecant button on your calculator, right? Sine, cosine, and tangent only. So what you're going to do is do the sine of 33 degrees. Okay? And you can put that all in parentheses if you wanted to and do this in one step. And you're going to raise that to the -1 power. That's going to reciprocate it.
There's a button right here.
No, there's not. Trust me. Just hold on. I'm going to explain that button in a minute. It's not this. Okay? That's the button on the calculator that I like the least. So if you do this, this would be the steps, right? The syntax on your calculator would look like this. Okay? Sine of 33 degrees raised to the -1 power. Because what does the -1 power do? It just, negative exponents flip things, right? So you can do that. On your calculator, this key is something completely different. As a matter of fact, if you put that in your calculator, it'll tell you there is no solution. Okay. That function is completely different. We're going to talk about that function in just a minute, but that's the inverse of sine function, not the reciprocal. And for that reason, a lot of calculators, and I really like them, the ones that do this. So incidentally, what's the answer here before we move too much further?
1.8361.
1.8361.
I did it with that button and without that button, and I got the same answer. But
No, you didn't. If you do second sine,
I didn't do second sine. I did that. It's right next to sine to the left. It's x to the -1.
Yeah.
That's what I thought. That's what I thought you were.
oh, okay, that button works.
Yeah, I use
Yes,
that button.
yes. I thought you were talking about the little blue thing that's just above sine. You see that sine -1?
Yeah, I saw that. But
Yeah,
I figured
I'm sorry, yeah. So, yeah, that button to raise something to the -1 power. So, yes, you could do sine of 33 and then hit that button and you're good. Yes, that button is good.
What's the apps button?
All right?
Use your abs, Judge.
Okay. All right. So how would we use this to solve triangles that look like this? We want to find the value of x. We want to find the value of x and round to the nearest hundred. Some of you aren't writing. Some of you are, which is a good thing. This will not mean anything to you if you don't write it down. You've got to write this down. Draw the triangle. What we're trying to do is find x. Okay? Now we're given a couple of pieces of information here. What are we given?
An angle.
We're given an angle. We're given us the two what?
The adjacent.
The opposite.
The adjacent. We're given the two legs, right? Which trig ratio involves the two legs only?
Tangent.
Tangent. So here's what you have to do to solve this problem. The tangent of 28 degrees is equal to what? X over 9. Okay? The tangent of x of 28 degrees is equal to x over 9. how do we solve this?
Solve for x.
Okay, how do you solve for x?
Multiply by 9.
Multiply by 9, right? If we multiply this equation by 9, or really we could kind of see it as cross multiplication. 1 times x is x. 9 times tangent of 28 is equal to x. Kind of like solving a literal equation, right? So then you take your calculator and you multiply 9 times the tangent of 28.
That's 4.785.
4.78.
54.
Let's see, it says to the nearest hundredths. So 4.79 is an approximation for x. Okay? Another one. This one says find the value of x and find the value of y. Round to the nearest hundredth. Again, draw the triangle. And we're going to use the trig ratios to solve for x. Why can't I use the Pythagorean theorem?
Because you don't have A and B.
I need 2 of the 3 sides to find the to use this. I mean, I know that x squared plus y squared equals 12 squared. But, oh my goodness, that's a circle. It's an infinite number of points that satisfy that equation. So, but I could find one of the values and then switch to the Pythagorean theorem, right? Or I could use trig ratios for both values. It's easy enough. What could I use to find x? If I'm given that the tangent, I'm given 52 degrees here, and x, and I know 12, what trig ratio is formed there? Sine. Why is that? Because it's the opposite side over the hypotenuse. So the sine of 52 degrees is equal to x over 12. And then we cross multiply and we get 12 times the sine of 52 equals x. And what value does that give us? 9.46 is an approximation for our value there. Okay. Now, that's pretty easy, right? You just have to identify. Now, to find y, I could take this and plug it into the Pythagorean theorem at this point, or I could use a trig ratio for y and the hypotenuse. I could say that the cosine of 52 degrees equals y over 12 multiplied by 12. That's probably easier than using the Pythagorean theorem to get y. Okay? Good enough? Now let's get to the sticky part of this. And I know we're going to run a minute or two over, but that's just the way it's going to be. Find the measure of angle A. This time we're looking for an angle. What do we know about angle A? Based on what's given here, what do we know about A?
It's adjacent to 6.
It's adjacent to 6, and the hypotenuse is 11. What trig value or what trig ratio is being found there? So cosine of A, here's what we know about A. Y'all ready? A has a cosine of 6 over 11. Okay. Now, the inverse of a square root is a what? Square. The inverse of the square is the square root. If I want to solve a cubic function, I use the cube root, right? If I need to solve a cube root function, I use the cube. All right? So to solve a cosine equation, because I'm trying to do this, I'm going to use the inverse cosine. All right? And that's the second cosine button. That's this button. If you don't punch this in and get this, you'll never remember it tonight. So take an extra minute and punch this in. A is the angle whose cosine, the inverse cosine of 6 divided by 11. And that'll tell you the measure of angle A is what? Approximately 56. It says to the nearest hundred. 56.94 degrees. Okay? You wish. Tomorrow, guys, we will go over the last couple days' homework. I know that that's just what we'll do in class tomorrow. So So have all your homeworks for the last 3 nights ready, and we'll do those tonight. Y'all have a great day.